So there are three components to the central enigma. The first is that cells will increase in number from one cell to billions of cells. Now, cell division is extremely important, particularly if you're studying cancer, but it's largely outside the scope of these lectures on embryology. And then cells will increase in kind. They go from one kind of cell, the fertilized egg, to many kinds of cell. It rather depends how you count it, but there are probably hundreds of different cell types, and these cell types are then divided into subtypes. So you're looking at a very wide range of sorts of cells, of kinds of cells, which arise during the course of development. So obviously one of our key questions is, how do those cells become different from each other? But that's not the only question. There's another question about how cells become arranged in space with respect to each other. So your arm and leg are recognizably different, and yet they're made up of very much the same kinds of cells, just arranged differently with respect to each other. They are deployed with respect to each other. So that's another thing that we're going to have to solve, another part of the central enigma that we're going to have to address. Now, you might be thinking that the answer is DNA. And it's certainly true that DNA is absolutely essential to developmental processes. I'm not suggesting it's not. But there's something you should think about, which is the fact that the DNA in all of your cells is identical. And therefore, when cells become different from each other, those differences cannot arise from the DNA. They reflect different patterns of DNA expression, but something has to make different parts of the DNA switch on or switch off at particular times. So there must be some other kind of information signal that's coming into the genome to allow it to specialize in particular ways. And the best evidence for this is Dolly the sheep, the first cloned organism. And what happened with Dolly was that the scientists involved took a nucleus from a differentiated cell. It was in fact a mammary gland cell. And they showed that that DNA could turn into all of the different kinds of DNA in an adult sheep. In other words, there was no irreversible specialization had taken place in the DNA at all. The best estimate is that any DNA from any of your cells is capable of giving rise to a complete organism. The DNA itself is not specialized.